There is a kind of knowledge that does not get written down because the people who have it do not think of it as knowledge. They think of it as just what you do, the way you press soil firmly around a transplant before watering, the way you water at the base of the plant rather than from above, the way you save seeds from the most productive plant rather than the prettiest one, the way you read the garden in the morning to know what the afternoon will bring. This is the knowledge that grandparents carried in their hands and in their habits, and that skipped a generation while everyone was buying bags of fertilizer and plastic irrigation systems that promised to do the thinking for them. Some of that knowledge has been recovered by the organic movement, by permaculture, by regenerative agriculture, but much of it still sits quietly in the practices of older gardeners who learned from their own grandparents and who have never been asked to write it down. Today, I am going to write it down. 15 techniques that working gardeners used for generations before the garden center industry gave us the impression that plants needed products, rather than understanding. Technique 1. The firm press after planting. Every gardener of the older generation pressed the soil firmly around every transplant and every seed with both hands, with a foot, with the flat of a trowel, not lightly, firmly. The reason is specific and biological. Air pockets in the soil around newly placed roots prevent those roots from making contact with the moisture and the soil particles they need to establish. A firm press after planting eliminates air pockets and creates the soil-to-root contact that determines whether a transplant establishes in 2 weeks or 8. Modern planting guides frequently say to firm the soil gently around transplants. The older approach was not gentle, it was decisive. The difference in establishment rate is measurable. The specific technique that older gardeners used for firming varied by plant and by soil type. For transplants in clay-heavy soil, both hands pressed down firmly on either side of the plant with the weight of the upper body behind the press. For root vegetables and bulbs planted with a dibber, the foot was used to press the soil closed around the planting hole. For seed rows, the back of a rake or a specially made tamping board was drawn along the row to press seeds into firm contact with the soil. The common element in all of these variations was deliberate physical pressure rather than the tentative padding that most modern planting guides recommend. The soil should feel solid after planting, not loose. If you can push a finger easily into the soil immediately beside a newly planted transplant, you have not firmed enough. Technique 2. Watering at the base, never from above. Before overhead irrigation became standard, and before the garden hose became the default watering tool, water was applied from a watering can with a long spout directed specifically at the base of each plant. This was not because overhead watering was unknown. It was because experienced gardeners knew that wet foliage through the night creates the conditions that fungal diseases require. Tomatoes, squash, roses, and virtually every other plant that is susceptible to fungal disease does significantly better when watered at the base rather than from above. The incidence of black spot on roses, of powdery mildew on squash, of early blight on tomatoes is measurably lower in base-watered gardens than in overhead-watered gardens. This knowledge predates modern plant pathology by centuries. It was simply observed and passed on. Technique 3. The double dig. Before synthetic fertilizers made it possible to grow plants in compacted, depleted soil by adding soluble nutrients at the surface, gardeners improved their soil physically. The double dig loosens the soil to a depth of 2 feet, allowing root systems to penetrate deeply rather than staying in the top 6 inches. The method involves removing the top layer of soil to 1 spade's depth, loosening the subsoil below with a fork without removing it, and then replacing the topsoil. This physically changes the drainage, aeration, and root penetration capacity of the soil in a way that no surface amendment can replicate. A double-dug bed produces visibly larger, more productive plants in its first season, compared to a conventionally prepared bed at the same level of soil fertility, because root access to soil volume determines plant performance more directly than surface nutrition does. The double dig is labor-intensive, and that is exactly why it fell out of favor when synthetic fertilizers made it possible to bypass the soil structure problem entirely by delivering soluble nutrients in a form that shallow roots could absorb without penetrating deeply. The trade-off is significant. Plants grown in deeply loosened soil develop extensive root systems that access a much larger soil volume, which means they access more moisture during dry periods, more minerals from deeper soil layers, and more biological support from the diverse microbial communities that occupy different depths. The yields are consistently higher, the drought tolerance is consistently better, and the plants are consistently more disease-resistant than equivalent plants grown in conventionally prepared soil, The double dig is an investment of physical effort that pays compound returns across the growing season. Technique 4. The cold frame and the hardening off. Before heating systems and controlled growing environments, every gardener who started seeds indoors understood that the transition from protected indoor growing conditions to the outdoor garden was a critical and potentially fatal moment for seedlings. The cold frame, a simple bottomless box with a glass or clear plastic lid set over a garden bed, served as the transition environment. Seedlings moved from the house to the cold frame, then from the cold frame to the open garden over a period of 10 days to 2 weeks. Modern commercial growing, which ships plants directly from heated greenhouses to garden center displays to outdoor planting, skips this transition entirely and produces the transplant shock that kills many otherwise healthy plants in their first week in the ground. Hardening off in a cold frame adds 10 days to the process and doubles or triples the establishment success rate. Technique 5. Companion planting from observation rather than theory. The companion planting lists in modern gardening books are largely theoretical, derived from limited research and frequently repeated without verification. The companion planting knowledge that grandparents carried was empirical. They had watched over decades which combinations produced more vigorous plants, fewer pests, and better yields. Basil and tomatoes planted together because the observed outcome was consistently better, not because a study showed that basil produces compounds that deter tomato hornworms. Carrots and onions interplanted because carrot fly avoids the onion scent, and onion fly avoids the carrot scent, and both crops performed better together than separately. Nasturtiums at the base of fruit trees because aphids that would attack the tree went to the nasturtiums first. The knowledge was in the observation, not in the explanation. The specific companion planting knowledge that older gardeners carried was also place-specific in a way that no general list can capture. What worked as a companion combination in one garden, in one soil type, in one climate, did not always produce the same results in different conditions. The grandparent who had grown tomatoes and basil together for 30 seasons in one garden had learned whether that combination worked in that specific garden, not whether it worked in theory or in controlled research conditions. This place specificity is something that modern companion planting guides, which offer the same combinations regardless of growing context, systematically ignore. The value of the older knowledge was not the list of combinations. It was the habit of observation that allowed the list to be verified and refined over time in the gardener's own specific growing conditions. Technique 6. Saving seeds from the best performers. Before hybrid seeds became the commercial standard, every gardener saved seeds as a matter of course, but the specific practice that made seed saving a form of plant breeding rather than simply plant preservation was the deliberate selection of the best performers, not the prettiest fruit, not the first fruit, not the largest fruit, the fruit from the most productive plant, the most disease-resistant plant, the plant that performed best in the specific conditions of that specific garden. Over decades of selection, this produced locally adapted varieties that performed in that garden's soil, climate, and conditions better than any purchased variety could, because they had been bred by selection specifically for those conditions. Modern hybrid seeds bred for commercial production conditions cannot be saved meaningfully. The practice of selection has been transferred from the gardener to the seed company. Technique 7. The morning inspection. Older gardeners walked their gardens every morning, not to work, but to observe. The morning inspection was a practice of reading, which leaves had changed color overnight where slug damage had appeared, which plants were showing the first signs of stress that would develop into a problem by midday, which volunteers had appeared in unexpected places. The morning light, low and directional, showed things that the even light of midday concealed. Dew on leaves made fungal problems visible before they were visible in dry conditions. The morning inspection was the information-gathering practice that made experienced gardeners appear to have an almost supernatural ability to catch problems early. It was not supernatural. It was a daily habit of disciplined observation. Technique 8. Making and using leaf mold. Every autumn, every leaf that fell in or near the kitchen garden was collected and composted separately from other organic material into what older gardeners called leaf mold. Leaf mold is not finished compost. It is partially decomposed leaf material, dark and crumbly, that takes 1 to 2 years to reach its most useful state. Applied as a mulch or incorporated into potting mixes, leaf mold improves soil water retention, supports the fungal networks that connect plant root systems, and provides a slow-release nutritional baseline that supports healthy plant growth without the surge and crash cycle that synthetic fertilizers produce. Most gardeners today either add leaves to their general compost pile or dispose of them as yard waste. A dedicated leaf mold pile is one of the simplest and most valuable practices that almost no modern gardener maintains. The specific composition of leaf mold makes it valuable in ways that finished compost cannot fully replicate. Leaf mold is high in carbon and low in nitrogen, which makes it the opposite of most compost materials. This high carbon quality makes it an ideal habitat for the fungal organisms that form mycorrhizal associations with plant root systems. When leaf mold is used as a mulch, it creates conditions at the soil surface that encourage mycorrhizal networks to expand into the root zone of surrounding plants. When it is incorporated into potting mixes, it provides the fungal habitat that commercial potting mixes lack. Seedlings started in mixes containing leaf mold establish faster and grow more vigorously than seedlings started in commercial mixes because they have access from the beginning to the fungal associations that support nutrient and water uptake. Technique 9. Planting by the signs of nature rather than the calendar. Older gardeners planted when conditions were right, rather than when the calendar said a particular date had arrived. Potatoes went in when dandelions bloomed, because dandelion bloom timing correlates with consistent soil temperatures adequate for potato germination better than any calendar date does in most regions. Sweet corn was planted when oak leaves were the size of a squirrel's ear, because oak leaf development is a reliable indicator of stable, warm soil conditions. These phenological indicators, the use of observable natural events to time agricultural practices, were accumulated observations connecting plant development in the wild landscape to the readiness of garden soil conditions. They are more reliable indicators than fixed calendar dates in most regions because they respond to actual conditions rather than assumed averages. The accumulation of phenological knowledge in a specific garden over decades produces a local planting calendar of extraordinary precision that no purchase planting guide can match. A gardener who has watched dandelions, oak trees, lilac bushes, and forsythia in the same location for 20 years knows exactly what each of these indicators means for planting timing in that specific garden's microclimate. The knowledge is hyperlocal, self-correcting, and free. It requires only the habit of observation and a willingness to record what you observe each year so that the patterns accumulate into reliable guidance. The notebook that older gardeners kept was often more valuable than any published gardening guide because it contained exactly the information that applied to exactly the conditions they were working in. Technique 10. The buried banana peel and kitchen scrap approach. Before compost bins became standard garden equipment, kitchen scraps went directly into the garden in a practice sometimes called trench composting or pit composting. A trench was dug beside a row of heavy-feeding vegetables. Kitchen scraps were buried in the trench and the soil was replaced over them. Within weeks, the scraps decomposed in place and released nutrients directly into the root zone of the plants beside them. No bins, no turning, no waiting for finished compost. The direct burial method is faster than conventional composting, requires no equipment, and places nutrients exactly where they are needed. It is still practiced in permaculture contexts but has largely been replaced by bin composting, which is tidier and more distant from the plants it is meant to benefit. Technique 11. Using diluted urine as a nitrogen source. This practice appears in virtually every pre-industrial agricultural tradition in the world. Human urine contains approximately 2% nitrogen in a water-soluble form that is immediately available to plant roots, along with phosphorus and potassium in useful quantities. Diluted 10:1 with water and applied around the root zone, it functions as an effective liquid fertilizer. Older kitchen gardeners used it as a matter of practical resource management rather than as an alternative gardening philosophy. The practice is biologically sound, economically free, and has been essentially eliminated from modern gardening culture by social discomfort rather than by the availability of better alternatives. Technique 12. The dibber and the proper planting hole. Before transplanting trowels, older gardeners used a dibber, a pointed wooden tool, to make precise planting holes for seedlings, bulbs, and small transplants. The dibber makes a hole of exactly the right depth and diameter for the root ball being planted, and it compresses rather than removes the soil at the sides and base of the hole, which provides firm soil contact around the roots immediately, without additional firming steps. Modern trowels loosen the soil in a wider area than necessary, and often leave the planted root ball sitting in loose soil that must be firmed separately. The dibber is a more precise tool for planting than the trowel, and produces better establishment results. It is still available from heritage seed and tool suppliers, but has essentially disappeared from mainstream gardening culture. The size of the planting hole also matters in ways that modern planting practice frequently ignores. A hole made by a dibber or trowel that is exactly the right size for the root ball places the roots in immediate contact with undisturbed soil at every surface. A hole that is too large leaves space around the root ball that fills with loose, poorly structured soil, reducing the immediate contact that supports rapid water and nutrient uptake. A hole that is too small compresses the root ball and prevents the roots from making their natural distribution through the surrounding soil. The older practice of making holes precisely sized for each planting was not fussiness. It was the understanding that the geometry of root-to-soil contact in the first days after planting determines the trajectory of the plant's entire first season. Technique 13. Protecting soil from rain impact. Before no-dig gardening became a philosophy, older gardeners understood intuitively that bare soil exposed to heavy rain became compacted at the surface and damaged in structure. They kept soil covered, with crops, with mulch, or with cover crops, through every period when a planting was not actively in the ground. The act of leaving bare soil between plantings, which is standard practice in most modern vegetable gardens, was understood by older gardeners as a form of soil damage that required repair before the next planting, rather than a neutral condition. The physical impact of raindrops on bare soil breaks the structure of the top layer and creates a compaction crust that inhibits seedling emergence and water infiltration. Covering the soil continuously prevents this damage rather than repairing it after the fact. Technique 14. Reading plant color for feeding decisions. Before soil tests became standard, and before the generic advice to apply balanced fertilizer on a fixed schedule became the norm, experienced gardeners read the color of plant leaves to make feeding decisions. Pale yellow-green growth on the lower leaves moving upward indicated nitrogen shortage. Deep green, almost blue-green coloring with slowed growth indicated too much nitrogen and too little phosphorus. Yellow leaves with green veins on young growth indicated iron or magnesium deficiency. Red or purple coloration in leaves of plants that are not supposed to be red indicated phosphorus deficiency, typically triggered by cold soil conditions. This color reading was not guesswork. It was an accumulated observational knowledge that allowed experienced gardeners to respond specifically to what the plant was telling them, rather than applying generic solutions to undiagnosed conditions. Technique 15. Finishing the bed before the season ends. The older garden was never left in the state it was in at the end of the growing season. Every bed was cleared, composted, and covered before winter arrived, not because the gardener was tidy by nature, but because the work done in October determined the quality of the soil in April. Organic matter incorporated in autumn had an entire winter to begin decomposing and integrating into the soil structure before spring planting arrived. Cover crops sown in September were established and actively fixing nitrogen, or protecting soil structure through the winter months. Beds left bare through winter lost organic matter to leaching, developed surface compaction from winter rain, and required remedial work in spring that could have been avoided by preparation in autumn. The autumn finish was not cleanup. It was investment in the following season. These 15 practices are not complicated. They do not require products. They require attention, observation, and a willingness to learn from what the garden shows you, rather than from what the packaging tells you. They are the accumulated responses of generations of people who depended on their gardens for actual food and actual livelihood, and who could not afford the luxury of not paying attention. That level of engagement with a garden produces results that no product can replicate, because the product addresses the symptom while the practice addresses the system. Drop a comment telling me which of these 15 techniques you already use, and which one you are going to add to your practice this season. I read every comment. Give this a thumbs up if it changed how you think about what your garden actually needs, and subscribe for plant knowledge and practical gardening technique every single week.